My name is Adam Schultz. I also work at B3 Solutions. I think all of us here work at B3 Solutions, so that should be good to start with. I'll be talking today about MVVM and WPF. Let's start with MVVM. First off, what is it? It's a design or a software architecture that's designed to separate out user interface design, business logic, and data logic. So this isn't exactly a language, it's more of an idea of how to approach writing software. The acronym itself stands for Model, View, and View Model. We'll dive into what each of those things mean and how to separate them out later on in this thing, but just to give you a quick overview, we have this little picture here to separate out the different ideas. The first one would be the view. That one would be like your pictures, what the user can actually see. The view model would be your business logic of how you want to show something on the screen. And then the model would be the data of the things you actually want to show something on the screen about. One of the big things about MVVM was that it was designed to make use of the data binding feature in WPF. WPF that actually is a language that uses MVVM. Again, we'll dive into that one in a moment here. But MVVM uses the data binding from this language to make it easier to separate out these different sets of logic. Data binding in WPF allows you to easily manipulate data on a screen with minimal code. So, very quick introduction on that, but we'll be diving into a lot of what these details mean in just a moment here. Before we get to any of that, though, I want to give you a little bit of history about MVVM. First off, it's based on a similar architecture, similar to MVC, which stands for Model View Controller. Have you guys seen MVC or any of these other architectures beforehand? Okay, so you have a little bit of an idea of what we're talking about here. It's just another architecture that you can use to design your software. So it's similar to that one. The difference is that your controller is now called a view model in here, and they behave a little bit differently. Specifically, MVVM was built for WPF and Silverlight. They both use .NET languages as their code behinds. That would be the actual code that you're writing. And we use this new language called XAML, or it's pronounced XAML. It's really just XML. We'll get into that in a bit too. So we have the separation of the front end and the back end code with these two different languages. It was announced in 2005 by John Gossman. At the time, he was a WPF and Silverlight architect at Microsoft. This is based on, going back to the MVC thing, the part that makes this based on MVC is specifically the part in MVC where you have a separation between the presentation layer, which we call a view in both of those two architectures, and the business logic, which is a little bit different in each of these things. While MVVM was announced 10 years ago, in 2005, it is still very relevant to today, and in fact, Microsoft encourages this thing. It's mostly used in a lot of Microsoft-based systems, like WPF, a lot of Windows Phone apps will use this, and they're encouraging Windows 8 apps too. More recently, it's been adopted as another design principle for Microsoft's, what do they call them? The universal apps. So this is still something that's very alive and well in Microsoft. So it's been around for a bit, and it's continuing to be used as well. It's also been adopted outside of Microsoft, specifically in Knockout.js, which is a JavaScript implementation of MVVM. That's something that gives you the bindings that WPF gives you to bind data to your view, but it's done in HTML and JavaScript. And I won't dive into any Knockout so that I don't steal the thunder from the other guys here. So you will hear about Knockout later. One of the big ideas of these architectures is a separation of concerns. What we want to do with this stuff is we want to make a strict distinction between what goes into the user interface, or what we're calling a view, and what goes into the back end, or the business logic of our code. This makes sure that when we separate these things out, we can have two different developers or two different teams working on just two different sets of code for the same application, but they're not dependent on each other anymore. For example, if you want to make, or you have a user interface guy, he wants to arrange the text box, he doesn't have to wait for the back end guy to figure out how to actually display the text box on the screen. He can just go right into working on that text box. Same thing goes for the business logic. He doesn't have to wait for the view guy to arrange it and choose the right color for where it needs to be. So you can separate things out and both work at the things at the same time. I also wrote down some buzzwords to make this nice. You can have productivity and time savings and everything that everybody likes about software code. So separating things out is a very good thing. With this sort of a divide, it's trivial to have a graphic designer or other UI position work on the layout control of a page without depending on the business logic. The inverse is also true. The business logic developer no longer depends on the user interface. So splitting things apart is a good thing. But why would we even want to do this? A lot of times user interfaces go through multiple iterations. If you've ever done anything where you start out where you want to have this great idea of what your application is going to look like, and then you finally get to the end once you've gone through that whole process, you might not have exactly the same thing, especially if you're working with a customer who halfway through the project, they can now actually start to see what these controls will look like. What they want to end up paying for the project might be a little bit different by the end of it. So you need something that'll be able to bend and flow with whatever your requirements end up being, and sometimes those things change. So separating the user interface and the business logic apart from each other allow changes to be made easily in the user interface without impacting the rest of the system. So mainly these changes come from the customer when they actually start seeing what the final product is going to look like. A lot of times when you can't actually show them something, you'll have to make a mock-up in a presentation, and you might not be able to get the full idea across to the customer, but as you get towards the end, they'll be able to start seeing what they actually want. To illustrate this idea, let me tell you a short story of my sister. She went to Grove City as well, and my family was helping her move into her dorm room. We moved all of her belongings into her room, and we got everything all nice and settled, moved everything in there, and then she decided that she wanted to start choosing where she wanted to lay out the furniture. It's great. It's her room. She can now do what she wants. So we moved the bed around, we moved the cabinets around, we start arranging her stuff. We arrange it, it's good, and then she decides, no, I want to move the couch a little bit over here. So we then move everything around, we're slowly moving the furniture around. We did this for, I'm not kidding, about 30 minutes of just moving after rotation, and we ended up in the exact same configuration that we started with. And that's the one that she chose. Designing user interfaces is much like arranging the furniture in a dorm room. You might end up doing a full circle with this thing, but the idea here in the separation of concerns is that you can react to these things without having the project fall on its face. Because even though you're arranging the user interface, your business logic is still the same, and that's still solid while you're reacting to any changes that the customer might hand to you. So again, separation of concerns is a very good thing here. So now let's dive back into what MVVM really is. We're taking this idea of the separation of concerns that come from MVC, which is the model, the view, and the controller. You're separating out the idea of your presentation layer from your business layer. But MVVM also includes the data binding capabilities of WPF. I know I'm using that term right now without really defining it, but we will dive into exactly what data binding is in a moment here. So basically it's how you actually take the data from your view model and put it into your view. So you've now decided what you want to do in your business logic and then display it on the screen. So MVVM is basically MVC plus bindings, and the bindings is the important part there. This is done in an attempt to have the view model and the framework drive as much of the application as possible. So you're not really writing any code that says, I want to show and hide this text box at conditional things. That's all driven by data instead. If you do this separation properly in MVVM, you'll actually end up writing very little code in your views. So if you separate your concerns out, the only thing that should go in your view is the information about that view and how to display a text box on the screen. The other way around is true. You should end up with almost no logic in your business layer that has anything to do with the view. All it is just about business logic at that time. So we're still focusing on this separation of concerns idea here. So let's dive into what each of the pieces of MVVM actually mean. We'll start with the model, since I think this one is the most straightforward. Basically, your model is your data. That's it. It's just data at this point. So the model is the application's representation of the data. This can either be an object represented by your data, or a set of data calls, for example, if you're talking to a web service or you're talking to a database. That would be the representation in your code of wherever your data comes from. This also includes any rules about the data itself. So that would be, normally this would be done by some sort of an attribute. It's not actual code that goes with it. It would be like a required field on a property, or any formatting requirements that this is actually an email address. It shouldn't just be a regular string, or it's a phone number and should be formatted like a phone number. That's all that would go into this thing. You would also have any required associations. For example, if a field is required, you would have that in there as well. So it's just data and information about the data that goes into your model. A good example of this is if any of you have used Entity Framework. Actually, quick show of hands. Have you guys used Entity Framework at all? one person, two people in here. Okay, have you guys, or you might have heard some of us giving some other lectures about our DAO builder, where we have some code that generates a structure from a database. It gives an object representation of anything that's in there. So we have a couple examples of what a model would look like. So yeah, another note I have on this is that any logic you want to include in the model is not done by actual code of saying that to verify that this one piece of code actually does exist. Most of it will be done through properties on your objects and attributes about those properties too. So again, the model is just the data. The view is another straightforward piece. It's just the thing that the user can see. A lot of times, especially on the internet, you'll see it referred to as the presentation layer. That's the piece that's actually presenting information to your user. Anything that's visible by the end user would go into the view. It also includes any logic about the view itself, but you have to kind of take a step back from the logic that you would be putting into the view. It's not any business logic that would go in here. It is just display logic. For example, should I show the text box with a red outline or with a blue outline? So you also include some styling changes in here too. So the logic is only about presenting things in your presentation layer. When you write your view, you should also assume that there is no business logic with here. All that business logic would be taken care of in a different class or in a different area of your code. In WPF, the logic about how to display things is more often done with XAML, which we will dive into later. That would be your front-end code. So a lot of times you're not writing C# or C++ or Java or anything like that. You're writing at least in WPF, you're writing in this XML-based language. Because of the separation between a view and your data and your business logic and all that stuff, there's also an implied thing here where you can actually reuse views. You can have a same view or a subset of a view to be reused across different things. For example, if you want to display a user or information about a user, you don't have to keep writing the same view over and over again. You can just reuse the thing and just bind it to something different. Same thing goes for the view models, which would be your business logic. The view models can be reused across different places as well. If you keep finding that you have to make the same validation against a user, you can reuse that same view model. So what is a view model? As I've said before, it's mostly just your business logic. You don't have any information about your data, and you don't have any information about your views. So there's no specific text box. Like this example I have right here, you don't write code anymore that says textbox1.text is equal to an instant string. You're now doing that through bindings instead. So the logic of how to actually do that is contained in your view model. The view model is responsible for exposing objects from the model, so that will be getting your data out of your model, in such a way that a view can consume it. So your view can now use these objects that are from your model. Normally this is done through properties in the view model, and then you bind them through the view. It's that binding that does the actual populating of the text box. You're not actually writing code anymore that says, pull this specific value and put it in a text box. You don't do that anymore. The view model also contains all of the business logic about an application. For example, when to show the text boxes, when to query a database, and when to actually hit save. Another way of looking at this is as the state of the data in the model. The view model contains information about the data in the model and determined what was passed to it from the view. That's what I mean by the state of the model. The view model contains enough information about the data in the model to determine when it is appropriate to save the data and when to read it back from a database. For example, if a user clicks on a save button, the view would pass that event to the view model. Note how the view doesn't actually do the saving in this case. And then the view model would notify the model to save that data. So it's passing that information down across these, from the view into the view model and then down into the model to actually do the saving. So in this scenario, the view has no knowledge that the database exists or that it's even there in the first place. The view is just a view. All it's doing is displaying data. Same thing goes for the model. All it knows is that there's a database and that it can get data from it and that it can verify it. So you're, again, splitting apart all of these logics into different sections. You can look at the view model as sort of a middle code between the view and the model. There's also an implied piece in here that's not in the acronym, and that would be the binder. This is the piece that populates the view with information from the view model. In WPF, this is just a simple, like in your view, you would write the word binding, and then that you would tell it what property to bind to. So it's done by writing a binding statements to display data from the view inside the view model. In MVVM, normally the binder is not code that you write. Most of the time it's done by the framework itself. This is the piece, this binder right here is the piece that makes MVVM possible, and also the part that makes it distinct from these other architectures that are out there. Outside of WPF and Silverlight, you may have to implement a binder, but most things that are geared towards MVVM, for example WPF, they already have that built in. In MVVM, this would most likely be referred to as the controller. It's not a one-to-one mapping here, but the closest thing to it in MVC would be the controller. In MVP, another one that's very similar to MVC, it will be called the presenter, the piece that's actually telling the view what to display. In WPF, the binder is implied, however, it is built into the framework, so you actually don't have to write this code. MVVM includes a binding mechanism that frees the UI developers and the business logic developers from directly depending on each other. So there is a recurring theme here, the fact of separating out all of these different logics into something else. So I know we just went through all those different pieces, and it might be a little confusing about which one goes where and what logic would go into which section. So let's go over that for just a little bit here. Anything concerned with the visual appearance of the UI or anything displayed to the user would be placed in a view. Anything that deals with the logical behavior of the application and any sort of business logic should be placed in the view model. This logic, this business logic that is, should have no knowledge of how it's displayed or even which view it would be used in. That's going back to the implied part where you can reuse a view for the same different view models that are out there. The view not only includes the actual controls, buttons, text boxes, labels, and things like that, but it also includes stylings of the controls. For example, how much padding to give it, what color it should be, what width it should be, and the actual layout of the controls too. Another note here is that it's common to extract those sort of styles into, I guess you could call it a style library, to be reused across different views. So the reusing of code and the separating out of code is again, a very common thing that's done here. However, those styles would still be considered part of the view even after you separate them out. They're just a reused part of the views. So at this point, I would like to give you guys a little bit of a quiz just to see if you catch up on what piece should go into which logic. And I do have to put a disclaimer out here. I gave it to the other developers here, and they got really mad at me on this one because they got a lot of the questions wrong. So don't feel bad about getting these questions wrong. And we'll just do this with a quick show of hands too. If we have code that determines how to display controls programmatically, would this go in the view or in the view model? An example of this would be conditionally showing a text box. Who thinks it's in the view? Who thinks it's in the view model? Or just about split on this one. This would actually go in the code behind of the view. Since we're split on this one, I'll explain why. This is part of the presentation thing. It's showing you how to display the text box and where it should show up on the screen. The thing is that it would go in the code behind, so you would actually be writing code for this, but it would be part of the view. Next one here. Question number 2. How about code that manipulates what items to show in a view? For example, what items you would want to show in a drop-down list. Who thinks it's in the view? How about the view model? I think it's the view model. You guys are right on this one. This is considered business logic and should be placed in the view model. How about code to highlight the color of a selected item in a list? How about the view? View model. You guys are right again. This is a style and should be defined in the view. Note that the list items themselves and the knowledge of which item is selected should be defined in the view model, but the color itself will be placed in the view. How about rules defining the fact that an email address is required on a form submitted by a user? Who thinks it's the view? How about the view model? This is the part that made all my coworkers really mad at me. This would actually go into the model. This would be neither the view or the view model. Normally, something like this would be defined by a required attribute on an object in the model. The message to the user that the field is required would be placed in the view, and the logic to know when to do that validation will be placed in the view model. For example, after a submit button click, you would then do this validation. That's the end of the quiz. You guys did about as well as my coworkers did, so we're good on that front. Now, the rest of this part, I'm going to give an example of what MVVM looks like, and to do that I'm going to use WPF. This stands for Windows Presentation Foundation, but nobody calls it that. Everyone calls it WPF. This is a .NET implementation of MVVM. It allows for easy separation of the user interface from an application's business logic. Again, a recurring theme with this presentation. In WPF, there's a heavy focus on bindings, which we'll dive into in a moment here. We also have the separation of logic, which would be based on the XAML code versus a code behind. Again, your view versus what code you should actually write. I do have to admit that this is pretty much my primary resource for the rest of this lecture here. I highly recommend this website, wpftutorial.net. You'll actually see some of the watermarks and some of the images in here. These guys have pretty much everything you need to know about WPF in here. So any questions about how to create a control, how to work with a text box, what each property should be, it's a great reference for these things. They also have a section comparing MVVM to the other architectures I was referring to, MVC and MVP, and there's a link there for that exact web page. So I've been talking about XAML, but I didn't actually define what it is. So let's dive into that for a moment here. This is the front-end code. This will be used in your MVVM views. It's XML based, so it should be a familiar language to most people who write pretty much any code out there. It's very similar to HTML because it's all XML based. This also contains the code behind, so you can write in this XML language, or you can also write in C#. But pretty much anything that you do in one could be done in the other. But this is mainly focused for views. Just a quick example of what it looks like. Note the XML styling here. We have a window, we have a grid, and then we just define a couple properties for them. But it's the tiered XML style of things. I'm going to go over a couple quick controls here so that you're not too confused when we get into the lab. I'm going to talk about the grid. Here's a link to, again, a WPF tutorial on what it looks like. This is very similar to an HTML table where you would have rows and columns. And the grid, you would define the rows, you would define the columns, so you would actually have to say, I want 3 rows and then I want 3 columns, and then you would have to associate a control to what row and what column it's actually in. So they're useful for using a very distinct layout of how you want things to always be in relation to each other. So a stack panel is similar to a grid, where you would then have controls that go just stack right on top of each other. And all you do with this thing is you just say, I would like a stack panel, and then you plop controls in it. So it's different from the grid, where you don't have to define rows and columns. You can just place controls into the stack panel. Bindings are the thing that would let you pass information from your view model and then back up into your view. In WPF, these are awesome because all you have to do is write the word binding, and then you tell it what you want it to bind to. I was actually trying to think of things that I could say more about binding here, and here are my notes. I like bindings. I find them simple because you really don't have to do too much more other than say binding and tell you what you want to bind to. Note on here is that WPF by default uses something called two-way binding. That means that you're not only reading from the value that you're binding to, you can also write to it. So for example, if you're binding a text box, when you first open the page, it will show the value, it'll read the value from the view model, and then if the user changes it, it can automatically update the view model for you. You don't have to do any other code. Again, that's driven by the framework. That's part of the bindings and the thing that makes MVVM MVVM. So what happens if you have something in your code behind where you do some business logic and you need to change a value? You need to somehow tell the view that that property has updated. Since we're no longer writing code to say view directly update this value, we have to have something that'll notify that. So we have this problem where we change something in the view model and we want to notify the view about it. In WPF, we do this through an interface called INotifyPropertyChanged. Basically what this thing does is if you've implemented this interface, when you change a property, that property will essentially scream, hey, whoever's listening to me, I changed. The views listen for that sort of a thing, and then they update themselves when this property is called. What this looks like, let's just say we have a class called myClass in this case. We inherit from INotifyPropertyChanged because that's how you tell a class that it's implementing an interface. And there are 2 pieces to this interface. We have an event, which is the piece that you would actually attach to, and the views do this automatically for you. And it has to follow this format, and it's the property changed one. Then we also have a method that would call that. This can be named whatever you want. A common convention would be to call it NotifyPropertyChanged or something similar to it. Note the null check in here so that we're actually making sure that somebody's actually listening to this event, and then we call that event to say that something was changed. And you're passing the property name to this method, and that's what will tell something that it's updated. How you actually use this then, you would have, this would be a full definition of a property, where we want to set a first name. Note in the setter here that if the value that we're trying to set that first name to is different from what it originally was, then we call that method in the previous slide where we notify that the property was changed, again passing the name of that property. So then the view will know to update itself. So just a recap here of how to use these things. This binding example will be updated from the view model when the user enters text. And again, just to write that, we write binding, and then we're binding to the first name property. So long as the view model has a property called first name, it will then be updated. If also in the view model we implement NotifyPropertyChanged, the text box will then update when we change something in the view model. Same thing goes, since now it's a two-way binding, we can now use it on either side. So we don't have to write code anymore that says textbox1.text is equal to new text. With these bindings, we just tell it that we want it to attach to the property, and then it will update, and then on both sides of things. So I know that was a very quick run-through of WPF. That's why I put the reference to the WPF tutorial in there. I do highly recommend digging into that site because it's a great reference for how to use these sort of things.